Since we have discussed in the earlier video about the power of accommodation, we also should discuss about the defects of human vision and their correction. The different problems people face are very common one that we call it short-sightedness, or we call myopia, far-sightedness, or we call hypermetropia. Other one is presbyopia, and the next one is astigmatism. So these are the problems normally faced by human during their lifetime, and these are defects which can be rectified by putting correct value of focal length of the lens. They can be corrected by using lenses of correct focal length, and the person can have a clear vision. This can be because of lack of vitamin. It could be according to the age, or it could be due to accident, or it could be because of by birth or disease, that or could be the side effect of medicine, that could be, or it could be also because of diabetic effect. So these sort of corrections are required, and there are certain measures to be taken, and what are they we'll be discussing right now. We know that a normal eye can see objects clearly from 25 centimeter to infinity. However, sometimes eye lens may lose their power of accommodation. As I told, there could be different reasons for that. In such conditions, the person cannot see objects clearly and comfortably. It takes a lot of stretch to see far objects. Like I am using a lens which is bifocal, we call it. I am using the lens for my far-sighted as well as for my short-sighted, because both I am not able to see. I cannot see things very close as well as very far. So I am using a lens which is helping me to get far objects clear as well as near object distinct and clear. Now, these defects in eye can occur due to weakening of ciliary muscles, change in the size of eyeball, irregularity on the surface of the retina, and the other diseases or other factors could also be responsible. These defects can be corrected by using of suitable spherical lenses. This can be changed with the using suitable spherical lenses. Now, there are mainly three common defects. The number one, as I told you, number one is myopia, second one is hypermetropia, next is presbyopia, and other one is astigmatism with the age it comes. Now, first we'll deal with myopia or short-sightedness. The defect of eye in which a person can see near objects clearly. Near objects can be seen clearly, but far objects are not even able to see clearly. The defects of eye in which a person can see near objects clearly but cannot see the far objects or distant object clearly is called myopia. Now, the defect is also called nearsightedness or short-sightedness. That means the person can see nearby objects clearly but far objects are not distinct and clear. Now, to remove this problem, we have to use a spherical mirror of perfect focal length. Normally, when we have this problem, we go to an ophthalmologist, or we call it eye specialist or ophthalmologist. They check us with the use of different types of lens, and they find out whether my vision is clear with the particular letters, small to big they show us, and then they can verify which particular power of lens is required, and the spectacles are ordered, or the lenses are given, the spectacles are ordered. In myopia, the image distance object is formed in front of retina. That means the far objects which are supposed to form in retina, it forms before retina. So the retina doesn't get the image. So the far point of myopia, eye decreases and become nearer than infinity. So the far point is not clear because the image is formed. The lens which should converge and send it to the retina converges far ahead than retina. That means the image is formed before 2 point, that is the distance between eye lens and the retina, in between 2.5 centimeter. That means the retina distance of retina from the lens to retina is 2.5 centimeter. Before that, the image forms. So the image is not clear because it has not formed in the retina. So it is because of the reason that the students suffering from myopia cannot read the writing on the blackboard, or from the last bench of the classroom, it becomes difficult to see distinct things on the blackboard, because for him near objects are clear but the far objects are not, because it is forming ahead of retina. Now, a person with myopic eye finds difficult while driving the vehicle. while he's driving a vehicle, he also finds difficult due to excessive curvature of the eyeball. As a result of excessive curvature, the focal length of eye lens becomes shorter and its converging power becomes more than usual. That means the converging power increases, so it converges far ahead than it should reach to retina. In such cases, the rays of light from far objects get focused at a point before the retina, hence image form in front of the retina, which is not clear and which is not distinct. Due to elongation. Why does this thing myopia happens? Number one is due to excessive curvature of the eyeball or due to elongation of the eyeball. When the eyeball elongates, the distance of the retina from the crystalline lens increases, becomes longer than the normal eye. In such cases, the image is also formed in front of the retina. Since the eyeball elongations, that means the length, that is the lens to retina lens distance is 2.5 centimeter. Now, since the eyeball is increased, the retina lens increases, the distance increases, hence the image forms in front of it and it's not distinct and clear. Now, in myopic, the converging power of eye lens becomes larger than the required to form the image on the retina. Therefore, the defect can be corrected by using proper converging lens, proper concave lens, using proper concave lens which diverts the rays of light, and it diverges and it will not focus in front of the retina but exactly on the retina. The concave lens of suitable power diverges the parallel ray of light distance object. The rays appear to come from far point myopic eye and finally converge in the retina by the eye lens. Therefore, this sort of problem of farsightedness can be removed by using proper concave lens of proper focal length, where the converging power will make it, where the diverging capacity will increase and the image will be formed exactly in the retina. For example, if a person is suffering, I'll just take an example. The far point of a suffering person of myopia is 100 centimeter. What should be the power of the diverging lens required for him to get this particular defect out? Now we know that U is infinity. U is the infinity far point, and the image distance is how much is it? Minus 100 centimeter. That means a person suffering from myopia to 100 centimeter. Now we use the lens formula. 1 by f is equals to 1 by v minus 1 by u. We get 1 minus 1 by 100 minus 1 by infinity is equals to 1 by focal length or 1 by 100. Or focal length is minus 100 centimeter. So we get minus 1 meter. Therefore, power is equals to 1 by f or is equals to minus 1 d. That is, the power will be how much? Minus 1 d of the person who is suffering from a farsighted of